community! So today I show you how I build my own training. Whenever you build your own training dataset, you have to focus on the task ahead. Now here a demo. My task here is that I focus on science projects. The European Research Council granted Frontier Research Grant, the best of the best. And if you are 2 to 5 years after your PhD, and your grant is granted, you get up to 1.5 million euro for 1 to 5 years. So this is the content that I'm focusing on. My domain is excellent science, European. Second, time. I'm interested in actual data where all the projects I'm going to look at should end in 2022 and the following years. So I'm not interested in what happened in 2005. I want a training data set that is actual. What is the content of those 1,000 project descriptions? And I'm focusing only on the scientific content. And then, sum it up, we create an in-domain data set for my specific task. So I do a task-specific data set. This is just a science domain data set. And what we have is, we want to create a labeled data set so that our BERT or SBERT model can activate supervised training on this. So we can fine-tune our SBERT model on our specific science sentences. And we can do then semantic research, you can do question and answer, you can do zero-shot classification, whatever you want. So this is the task we set out to do. You want to create your own training data set, you have to decide on the structure. And what I like, I do it according to the most famous data set, the Stanford Natural Language Inference data set. And if you remember it, great. If not, here a short refresher. If you download the all NLI, so this means the Stanford and the multi-language NLI, this is exactly what is the structure of this specific data set. You have a sentence 1, and you have a sentence 2, and you have a label. And for each sentence 1, you have a particular sentence 2 with the label neutral, a particular sentence 2 with the label contradiction, and a particular sentence for this always the same sentence 1, now with entailment. Entailment means, yes, there is a semantic correlation. Contradiction explains itself, and neutral is, hey, it could be true that there is a semantic correlation between sentence 1 and sentence 2. So this is the structure of a training data set for SBERT that I want to emulate. So I'll have to have one sentence 1 and a sentence 2 and a label. And you remember, with SNLI, we had 750,000 sentence pairs. So my sentence pair, sentence 1, sentence 2, and label. This is a sentence pair with a label, and they had 750,000 of those. Now, I do not want to have a general app. I want to have a science-focused only. So what I try to do, instead of 570,000, I will go with 100,000. How to create 100,000 of those sentences. This I want to show you in a very easy example. Let's go back where we were. Yes. So where are we? I already had a pre-run just to show you. This is my Scratch Jupyter notebook where I'm working on. And let's say I have here a data set where I have here for each project. Now I have 461 projects selected. I have here a project description with 10 or 12 or 15 sentences. I have a start year and I have an end year, and I take all the end year greater or equal than 2022. So I want to have a look in the future, what science is coming up in Europe at the end of this year and the coming years. That has been approved, that has been funded. So I focus now on the objective column because there is the information that I need. I rearrange the index, yes. And maybe to show you, yeah, I have here now one project description here. You see this is one project description here in string. And as you can see, there are several sentences. And of course, you have comma and you have parentheses and you have special characters and whatsoever. And I even want to get rid of a comma because I'm interested in the content and not in the comma structure of sentences. It's upper scale or lower scale, whatsoever. I have to clean this. So what I do, I simply assign a new column, and then I apply here. As you can see, I have decided a class. I call it my clean, my function. And then I just clean it and I put the clean text in a new column. And this new column I call objective new. And if you want to have a comparison, this is objective, this is the old uncleaned text, and this is now the new clean text. And if you compare those two, you see here, it's all lowercase and there's no comma, there are no particular special characters, everything is gone. So this text is clean according to my task that I needed. Then of course I want to separate the sentences in own sentences. And to be sure, I assign simply a tokenizer, a sentence tokenizer from NLTK. This is standard procedure. And what they will get, and just show you, it's also a new column now in my data frame. In this new column, I call S combination. And if I want to show you how this combination looks, and I see now after each sentence, I have now a very particular pattern. And in my case, I have two blank spaces. You can choose whatever special character you like. So I do not rely simply on the dot, because sometimes you have space and dot, or you have dot and space, or dot and no space at all and whatsoever. Yes, then I assign this, and then I finally have my sentences. And then if you have your sentences, yes, what you can do is, of course, now you can split it and you can get single sentences. Now this is very easy. We just split it on the double blank space in my case, and I get my single sentences. And as you can see here, I have now my column here, single sentences, and I have 5,188 single sentences now from within my specific ERC projects. Now the next step is interesting, because now I have to decide which sentences should have the label entailment. Now I do it in the most simplest way possible. Like in Word2Vec, if you're familiar with this, I now take this summary of the project descriptions, so these 10 to 15 sentences, and I calculate the Cartesian product of these sentences. So I say, if I have a project description, highly specific, highly scientific terms, and I have 10 sentences in this project description of this one project, I now say all the combination of these 10 sentences get the label entailment. They have a semantic correlation, because all those 10 sentences that describe one scientific project have really a physical, a chemical, whatever, IT, correlation to each other. They all describe one project. So I totally let go of the lexical similarity, if you want, from sentence 1 to sentence 2, and I focus on the semantic content. So I say I create now from all those sentences all possible combination. It's called Cartesian product. And therefore we just use, let's have a look at this. Here, the command, if you're familiar with it, the iter tool combination. This is a beautiful command and does exactly what we need. And they give us now here the list. And if you want to have it in a Panda data frame, I convert it in a Panda data frame cell, and I have now a tuple. I have a tuple, a sentence pair of sentence 1 and sentence 2, and I know that all my tuples I have the label entailment because they are correlated. And if they are within one project, so those 10 projects, there's 10 sentences describing one project, only those 10, the combination of them, the Cartesian product of them, gets entailment. And this is easily done with the code. And yeah, hundreds and hundreds and thousands, and you can do it with list comprehension. Yes, a little bit more elegant. And so here you see now the first shimmer of my own data set on science. I have a sentence 1, and again, like I showed you with SNLI, I have now the first sentence, I think 10 times, and I have for each of this first sentence now all the other sentences in the single project description. And since all the other sentences in this single project have an entailment, so for all good public policy sentences, I have now 10 sentences that have a positive entailment. And then you go on and you go on and you create now 27,898 sentence pairs. And I have it now in a Panda data frame available for me. So the first task is, and remember we have to have 3 labels, just to remember, in the SNLI we have the label neutral, we have the label contradiction, and we have the label entailment. So entailment, I have close to 30,000 sentences. Now, neutral. Neutral is really, really critical. Let's go back. Neutral, where's my neutral? It's just a scratch, so I don't. This is my positive. We just have been there. You run through this. Yeah, and this is the end of the list description. So, neutral. For the neutral sentence, semantic labeling, this is a difficult decision. You have to think about this for your specific task. Now, in my case, I choose now projects that will end in 2022 from startup companies or high-tech SMEs with their scientific portfolio. And what I do now is I take those project description from the SME and I need now a neutral sentence level from sentence 1 to sentence 2. So sentence 1, I have to take my ERC grant projects like before. But now the sentence 2 with a neutral semantic context correlation, I choose from startup companies or high-tech SMEs. So you see, it is more or less, if you want, you can say this should differentiate between 3 labels. Pure academic research. In the middle, you have startup companies, high-tech, small and medium-sized companies. And from the contraception, we will have a look, and those will be purely industrial projects. So how we do this? Not easy. The first part we already have. The ERC grant project, I have my single sentences. And then I choose how many neutral sentences I want to add. Now I go here, sentences multiples for neutral and contradiction. I have 1 classifier. I say, so for every ERC sentence, I want to have 7 of the other one. So I look now at the SME project, so at the startup projects. I do the project descriptions, I extract them, everything as before. I clean the sentence descriptions of the startup projects, tokenize their sentences. It's absolutely the same as I showed you before. I create my single sentences. I do all on a Panda data frame. If you do it on a distributed system, of course, you would need a Spark data frame, but I'm here in 100,000, so this is really, I don't need some big data science. And now I have here, as you can see, 6,700 sentences from my small and medium-sized high-tech project descriptions. So I have chosen to stay in domain. Now the first domain was scientific excellence. Now here also I'm focusing on the technology content, not on politics, not on music, not on painting, just science and scientific R&D. Yes, done. So I construct my lists. So now you can see here, for example, I have the list of all my single sentence from the ERC. Again, good public policy. And there I have, I don't know how many thousand sentences. And now from the column SME project description, I have now here a cleaned sentence representation. Yes, you can copy this just to make sure. And then I randomly add those sentence lists. Okay, interested in everything of them. Same for SMEs, we just run through the code. It's a little bit boring. But what we end up with, and this is what I want to show you, I have now, again, 10 times the sentence, the first sentence from the ERC dataset, good public policy. And now all those sentences, all sentences too, are not from the same ERC sentence correlation, but are now from the high-tech startup or high-tech SME project descriptions that will also end 2022 or 2023. And between those sentences, I construct now, I define now a label that is neutral. So I say, both sentences have something to do in the domain science. But sentence 2 is not academic research, but sentence 2 is coming from the first step of a commercialization of research. So I decide to give this sentence pair the label neutral. And as you can see here, I constructed in this way 36,316 sentence pairs with neutral. And then you save it, of course. And now, and this is the easiest part, the last label that we are missing is contradiction. And now I choose a pure industrial program, of course, with a scientific content, but whenever an industry implements some new technology, it is tested for years, it has been evaluated, it has been fine-tuned, whatsoever. So you know this is now an industrial set. So for the negative semantic label or the contradictive semantic label, I choose industrial R&D projects finishing in 2022, take their project summary sentence as within the science domain, but not within the frontier science domain. So I stay in general within science. My vocabulary will be only a science-based vocabulary with a little bit of startup terminology, but this is it. So no music, no politics, no news, no art, science only. I get a real specific data set based on a science domain. So what we do, we run again through all the different, we construct our data frame, we extract now the project description of the industrial projects. We run through each and every step again. Sure, we could alter this and make a much nicer and much simpler, much more Pythonic way, but come on, this is just to show you in theory how I construct my data sets, my specific data sets, my task-specific data sets. Come on, and then I save it. Come on, collab. It's not so complicated. So here we end now with this contradiction label dataset. I have again my good public policy sentence 10 times. And now the sentence 2 is from the pure industrial research domain. So again, science, but now contradicting the academia research. I don't know if it really exists, this academia and industrial, but if you think about it, if you are 5 years after your PhD and you're working at the university, you're at the long-term strategic planning. And sentence 2 in industrial is the immediately industrial application of proven new technology. So, and I have my sentences, and I have again 36,000 sentences. So you guessed it. Now I just concatenate those 3 datasets. I stack my 3 pandas together, and now I get a new dataset, which has exactly what I want. I have a sentence pair, sentence 1 and sentence 2. I have a complete 3 label set. I have entailment, I have neutral, and I have contradiction. And I've achieved my goal of constructing 100,000 sentence pairs in 10 minutes, for example. So, and then of course, since we also want, when we run our SBERT or BERT model, we want to have an evaluation dataset available within our domain-specific dataset. So what I do now is I just sample out of this 100,000. I say random sample 5,000, take 5,000 out. And from those 5,000, please assign not this is the training set. So say this is my evaluation set in my training data set. And as you can see here, the result now, this is called my data frame 2. I have here again, good public policy, 10 times my good public policy sentence from the ERC. And then I have my 3 labels, entailment and something. And then now I have train, but here you see I have now the first of my 5,000 randomly chosen evaluation training set. Somewhere there again, there's another one. So in total, I have 100,000 sentence pairs and 5,000 evaluation training data sets. And this is it. And then I just say, okay, please, this is my, not my CSV, but my TSV file, my tab separated file. And then, because we want to save space, we want to transfer this, I say, okay, now generate a gzip file for me. And there's an easy command how you can do this, and you create your gzip file. This is it. Now I have my personal science only in-domain training dataset created. This is it. In the next project is now you say, okay, this is your dataset, but is it really working? Because you have a lot of assumption that you do not have to have a lexical overlap between in sentence 1 and sentence 2 of your sentence pair. So let's have a view what's going to happen. You take 5,000 project, you take 50,000 sentences from, for example, excellent science project in Europe ending 2022. So you want to know what scientific knowledge will be available in Europe at the end of this year. And this is your project description, your sentences, and you use this corpus of project description, this corpus of 50,000 sentences or 100,000 or whatever, 1 million sentences, and you create a data set, a training data set for your SBERT model or your BERT model. You can use it for both, and this is the beauty. I will show you in the next video. We created some labeled data. We created a labeled data training set on a domain specific to our task. I wanted to have a scientific training data set, and we have it now completely labeled. So we are in, you remember, we have the supervised training and the unsupervised training regime with SBERT or BERT, and we are here, since we have now labeled data, in a supervised training. We have a golden data set. This data set that we just created, this is called a golden data set, because we know exactly that the semantic content of this sentence to the semantic content of this sentence is given as a positive correlation, an entailment. And this is given for 100,000 sentences, and if you have more resources, you can take it to 1 million sentences or scale it to 10 million sentences, depending on the complexity of your domain-specific knowledge. So we created our label data. We have now in the area of supervised training for sentence transformers for SBERT or BERT. Now, in the next video, in the video behind the next video, I will show you can train your sentence transformer, your SBERT model, for example, on an official SNLI dataset. This SNLI dataset has common knowledge. There's some basic syntax of the English language. you have a transformer model that is fine-tuned on the SNLI dataset. And then you continue training. And then you take this SBERT model and you continue training now on a training dataset. And either you can choose some of the major training datasets like SDS benchmark, or you choose what we just constructed, your own dataset, like my dataset I showed you, my 100,000 sentences, so I can continue training my SBERT model or my BERT model, either it's a bi-encoder or a cross-encoder model, on this dataset. So this is it. In the next video, I will show you that this training dataset, we will now take it and we will train an SBERT system in detail. Thank you, and I see you in the next one.